This is a video from section 6.4 in a Calculus 2 class. We're going to look at problem 19, which is called the leaky bucket problem. A leaky 10 kilogram bucket is lifted from the ground to a height of 12 meters at a constant speed with a rope that weighs 0.8 kilograms per meter. Initially, the bucket contains 36 kilograms of water, but the water leaks at a constant rate and finishes draining just as the bucket reaches the 12-meter level. So the question is, how much work is done? So we need to find the work required to move the rope, the work required to move the bucket, and the work required to move the water inside the bucket. That, by the way, is leaking at a constant rate. Okay. Now, I need to place the 0 at the bottom of the rope with the positive direction going upward. So 0's right here. And I'm going to take a piece of that rope of length delta y, and I want to find the work required to move that piece of rope. Now, the distance from this piece of rope to the 0, we're going to call y. Now, if we look back, it's a 12-meter rope. And so this distance here is 12 minus y. Okay? Now, again, we have 3 pieces. So we're going to let W1 equal the work required to pull the rope, W2 equal the work required to pull the water, and W3 equal the work required to pull the bucket. Now, again, for W1, we want to find the work required for a piece of the rope of length delta y meters to get to the top. Now, the mass. We need to calculate the mass. The mass is equal to 0.8 kilograms per meter times delta y meters. Notice how the meters cancel and we get 0.8 delta y meters. Okay, so that's just mass. The force is 9.8 times 0.8 delta y, which is equal to 7.84 delta y. The distance that that piece of rope moves is 12 minus y. And now we're ready to set up our integral. So W sub 1 is the integral from 0 to 12 of 7.84 times 12 minus y dy. Well, that's 7.84 times the quantity 12y minus 1/2 y squared, evaluated from 0 to 12. And when we plug that in, I claim we get 564.48. Now, let's take a look at W2. So we want to find the work required to move the water. Now, this one's a lot trickier, so see if we can track what's going on here. At height 0 meters, there is 36 kilograms of water in the bucket. As an ordered pair, we can write this as 36, 0. At height 12 meters, there's no water in the bucket, so as an ordered pair, we can write 0, 12. Now, so we're given the ordered pairs 36, 0, and 0, 12. And I want to go back just a few steps here. Now, remember the water leaks at a constant rate, right? Which means there is going to be a linear relationship that's being described here. Okay? It's linear, which means when we go back, and we're over here, we need to find essentially the equation of the line through the points 36, 0 and 0, 12. The slope is equal to negative 1/3. So there's a relationship between x and y, and then namely, y is equal to negative 1/3 x plus 12. Now, x is the number of kilograms of water at a certain height, right? Y is the corresponding height of the bucket. So we have a certain number of kilograms of water, and then we have the height of the bucket. Solving for x, I claim we get x equals 36 minus 3y kilograms. And remember, that's a unit of mass. And so the force is equal to 9.8 times 36 minus 3y, which is 352.8 minus 29.4y. And now I'm ready to integrate that. So w sub 2 is the integral from 0 to 12 of 352.8 minus 29.4y dy. And when we go through that integral, I claim that we get 2,116.8. So let me reiterate that that's the work required to move the water. What about the work required to move the bucket? This one's the most straightforward of the three. The mass of the bucket is 10 kilograms. So the force is 9.8 times 10, which is 98. Okay? So the bucket moves 12 meters. And so W sub 3 is 98 times 12, which is 1,176. So W is W sub 1 plus W sub 2 plus W sub 3. And so we get 564.48 plus 2,116.8 plus 1,176 for a grand total of 3,857.28, and the units for this work is joules, right here. And that'll conclude this video for the leaky bucket problem. Okay, thank you.